Which one of the following well-formed formulae in predicate calculus is not valid? We have been given 4 formulas here and we need to find out which one is not valid among these. So this is a question from propositional logic. Now we will try to go through these statements one by one and see which of these is not valid. The first one says that for all x p of x implies for all x q of x. That will imply there exists x negation of p of x or for all x q of x. Now looking to the first part, for all x p of x implies for all x q of x. This is of the form A implies B. Now A implies B we can write in the form of negation of A or B as well. So this A implies B, we can write it as negation of A or B. So negation of this part is for all x p of x, the negation of that is there exists x such that negation of p of x. That is negation, there exists x such that negation of p of x. What this means is that there exists x such that for which p of x is false. Here what this means that for all x p of x is true. Now this one's negation was there exists x negation p of x, or this part we will write it straight here for all x q of x. Now this is same as writing A implies B implies negation of A or B, meaning this one is correct. The statement is correct. Okay. Now we look at B. There exists x such that p of x or there exists x such that q of x implies there exists x such that p of x or q of x. What this says here is that if there exists x for which p of x is true or there exists x such that q of x is true, which means that for some value of x there is at least one of these will be true, which meaning that either there will be at least one value for which p of x is true or there will be at least one value of x for which q of x is true. Now if there is at least one value of x for which p of x is true and there is at least one value of x for which q of x is true, we can definitely say that there will be at least one value of x for which p of x or q of x is true. Now that is same as written here. So see, let us say for x equal to 3, let us say p of x is true. Now for that value, for x equal to 3, we can definitely say that p of x or q of x is true because p of x is true for that particular value which we took. So this implies this is also correct. Now looking at option C, there exists x such that p of x and q of x implies there exists x p of x and there exists x such that q of x. Now here it is saying that there is at least one value of x for which both p of x and q of x is true. Let us say for x equal to 3, again p of x and q of x both is true, which will imply that there exists x p of x is true because at value of x equal to 3 we have this as true, and there exists x such that q of x is also true because at the same value we know that there exists x such that q of x will also be true. That value is given as x equal to 3 because we took x equal to 3 the same value here. So saying that this implies this is also correct. C is also true. Now looking at option D, for all x p of x or q of x implies for all x p of x or for all x q of x. Now this is not true. I will show you an example to show that this is not true. Let us say p of x means p of x says that x equal to 1. So p of x will be true if x is 1, otherwise it will be false. Now let us say q of x says that x is even. So q of x will be true if x is even, otherwise q of x will be false. And let us say x ranges in values 1, 2, 4 and 6. Okay, so this is the domain. Now for all x p of x or q of x will mean for all x either p of x is true or q of x is true. That means for all x either x is 1 or x is even. That is what q is. Now that satisfies for all x. For 1 x is 1 is satisfied, for 2, 4 and 6 x is even is satisfied. So for this case saying that for all x p of x or q of x is true. Now they are saying that if this is true, that implies for all x p of x or for all x q of x is true. Now this is false. What is for all x p of x? For all x p of x means for all x equal to 1. Now that is false because for 2, 4 and 6 p of x will be false. Now again looking at this part, for all x q of x, again that is also false. It says that for all x is even. Now if you can clearly see there is one x equal to 1 which is not even. So this part is also false. So this implies this is not correct. and they were asking which of the formulae in predicate calculus is not valid, meaning option D is the right answer.